Are you running agent systems at the moment? Like, you spending money, or are you just curious how much it costs in general?
Yeah, it's more that like, I have to believe. So I'm so no agent systems right now, but I'm a product manager in a Fortune 100-ish type thing, and so the challenge is that you're dealing with petabytes of data and lots of things, and so anything that of any scale, anything implemented would be probably of a decent scale at any point. And so if it's an expensive call, then it gets expensive really, really fast. And so, I just I don't have a mental model in my head of, well, would it, how much would it cost to do it the agentic way versus a more classical ML way, or even just a prescriptive rule-based structure, in
Sure.
general.
Yeah.
Is it a 10x cost, or is it like every call going to cost you through the agentic system going to be like $3 a call, or is it going to be like 3 cents a call? I don't even have a good, like, and I know there's like, oh, well, you can use the non-top tier agents, but I don't even have a concept of does that save you 5%, or does that save you 90% if you use one of the lower tier? Because like I said, I've never plugged in and looked at the token costs or anything like that.
So it's getting cool. Yeah, I mean, I'm happy to answer those questions. I don't know how much info you want. If you tell me you don't have to say company, but if you tell me what industry you're in, I can maybe tailor it a bit more as well.
Yeah, so I'm in the agribusiness industry in research, and so like some of the call structures, it might be that you're looking through sort of genomes and stuff like that, and so you'd be asking for predictive outcomes, and so um, you might be trying to in my head, and I haven't gone too far down this path, but like, you may want to disassociate from a single task into a single call to a multi-call with verification and double checks, or you're trying to do a prediction at an individual level, but then aggregate an experiment as a whole. So you sort of got individual level, and then somebody figuring out, um, kind of like you have the problem of like, who is the best players in a basketball league, but then also who do you want to have on your team, which is different. You're not going to just take the top five because they might all be, centers or point guards or something.
Yeah, you got a money ball it, man. That's it.
So you might have multiple agents doing sort of the different steps, but I don't have a concept of, if you're trying to do 1,000 predictions um, off of, if some of the thing, like, generally you're calling like a AWS large server for compute just for the ML models. What would be the equivalent?
Yeah, a few questions in there, and I'll say kind of off the bat, like, I do work with a lot of these systems, so I'm a technical founder, and I have to build a lot of these stuff in companies like similar to yours, not necessarily in that industry, but at least associated. Um, I am pessimistic about cost short term and kind of optimistic long term, to give it a framing. What you described, like, if you go from the top performing agent, which at the moment would be O1 preview from OpenAI, and then you take that down to a self-hosted, and I mean cloud hosted, not locally hosted, open source model, it can be like 10,000x difference. So there is actually like a really large variety in how much each call costs. And then you're more realistically looking at a long tail on the cheap end, but then significantly worse performance. So it's like, If you look at like GPT-4o, which is kind of one of the main OpenAI models, and then you look at 4o mini, again, you're probably looking, depending on your rate, at about 50 to 100x reduction again.
Okay.
And
So some big swings.
big swings, yeah. So it actually does really determine. And then GPT-4o is another 100. GPT-4 is like another 10x on top of that. Then the preview model. So like even within one company, let alone, and Google has their own offering, Anthropic has their own offering. It's a bit tighter coupled, but there is a big difference. Now, to that point, most of them are like, I'm just going to ask an LLM a question. I'm going to get an answer back. And that's pretty easy to track as a cost. I'd say the two things you care about when it comes to like, and look, multi-agent systems have been around forever, right? It's almost odd that I live and work in San Francisco, but it does feel like San Francisco is like reinventing this already running wheel of multi-agent systems. But to that point, stacking them together adds up cost really quickly. And it's not just an addition, because the more agents you add, the more complexity you add, the more verification you add. So it's kind of like this exponential running process in terms of cost and also in terms of uncertainty. So to your point before, if we look at, again, like selecting an NBA team, being like, get me all the players is like a pretty easy thing to do, right? So that's like a cheap call. And it's like, tell me which of these players are centers and then tell me which of these players are guards. It's like, again, relatively easy task. I'm pretty sure you brought up basketball. I'm a big basketball fan. I don't know how much you follow the NBA, but if you take someone like Nikola Jokic and you're like, he's a center, and it's like, but he does not play like a center would, right?
Mhm.
Kind of operates as a kind of like point center, if you want. Like there's complexity there, right? And that's like outlying value. How do you get an agent to identify that? Then you have to spend the money on the ones that cost, and you also have to identify where those decisions are. So when it comes to the cost of agentic systems, it blows up in cost really quickly. If you don't have like a good idea of how to use one agent, and then you want to add them, it's going to get worse. But in a perfect world, if you're willing to spend the time, there's kind of two associated costs, right? There's the step one to end cost of how much does it cost to run each agent. And that can be a little to a lot, and it varies widely when it comes from like open source models that you host yourself all the way up to your O1 previews, let alone a fine tuned model you run yourself. And then second, it's the step zero cost of the labor of figuring out which of these agents to run and why, and how to build a robust system such that you don't have to update it too much in the future. This is kind of why I say pessimistic short term and really optimistic long term, especially when you get vertical specific. You're able to identify the tasks that are like really repetitive, mundane, easy. If you can identify those tasks, then it actually is like very automatable. Like there's someone's job is just to move data from one place to another. It's like having one to many agents that do that. You can use the cheap models. You can instruct them really specifically. You don't have to have it. Again, finding the agentic system that's able to sift through all of that data and find the anomaly. Now you're starting to be like, well, is this worth it, or should I just keep the existing, like you said, like procedural systems that are in place? So in my opinion and in practice, and I do advise companies on literally the cost of implementing these multi-agent systems. It's like a multi-agent system doesn't solve your single agent system problem. So figure out the single agent system first, and then you can decompose it and start to actually save money. There's a system in which multi-agents save money. The majority of my time is telling people do not use a multi-agent system yet, because it's clear you don't understand, which is no one's fault, but like you don't necessarily understand how to decompose this and then extend it. And if you don't understand, more agents can mean more tasks, can mean more validation, can mean more experimentation, and that cost just blows up and is actually pretty difficult to constrain. And if you want to do the simple solution of like, okay, well then every agent just uses like the cheapest model, it's like, cool, well then you're not going to solve anything. It needs to be understood that, like you said, a workflow is a decomposition of tasks, right? And some of those tasks are really easy and repetitive, and therefore you can start to automate that. To that point, I'll use an example of where we worked with a law firm of being like, look, this task is impossible to automate. And if we, did a multi-agent system that solves this task, it's going to cost like either like way too much, and I'm not even confident can solve it yet. And we have regulatory issues, right? So it's like, how do I even do this? What we were able to do was like speak to them, work with them, break the like workflow down into its components. And then a multi-agent system doesn't have to just be agents. We just sent the complexity and also the regulatory task and made sure that an attorney was the one who like clicked it. And if they do that, A, it's compliant, and B, there's been some human in the loop there. So like that was actually able to massively save on cost because the agent costs like paled in comparison to the existing labor and like downtime productivity loss. So I'll stop there. I'm just kind of ranting at this point, I guess. But it's like that's kind of how I see that multi-agent systems naively can be much more expensive than people expect and also not solve problems. Multi-agent systems in use for like decomposing and then compartmentalizing and then solving specific parts of workflows can be really useful. And then yeah, finally it's like it really is like a 10,000. That's extreme. More realistically, you're probably looking at 100, but to be genuine, it's like 10,000x difference between the top and the bottom models. Hey guys, no pressure to put video on, but if anyone's got questions, type them in the chat or say them out loud. Otherwise, Eric, feel free to jump in. But yeah.
So do you normally say, well, why don't you just have one single agent with a very expensive model with a good set of tools and start there, and then only once you figured out that do you cost optimize by decomposing and moving the smaller tasks to lower cost models? Or is it more that you kind of have to decompose it anyways, um, because the prompt gets too long for multi-step, and you it's just a process dependent approach?
Yeah, if I'm honest, I never have context window size problems ever. I think if you're starting to have a prompt that's too long, you're probably asking a model to do too much. Like even the best models actually perform better with a less of a prompt. But even further than that, let's say you want to run a task 1,000 times, a lot of the cost is associated with the input tokens. So like if you add an extra 1,000 tokens per prompt and you do it 1,000 times, right? You're now looking at like a significant increase of the cost over time. So to describe process, in a perfect world, yes, like map out your process exactly, and I can tell you which parts you should make an agent, which agents are recommended, how much time you need to spend on the prompting, what examples do you need, etc. Like, do you need to fine tune? The answer is almost always no, but when it's yes, it's like definitely yes, like those sort of things. However, I'd say in practice, most people just want to know if it can be done in the first place. Like what I just described is significant amount of effort, right? And potentially requires different people from the business to all be in the same room talking about it. And that's like not an insignificant amount of cost, right? So more realistically, it's what you just described, which is like, look, just get the best agent, see if it can solve this, do it on a significantly reduced set of data or problems, at least try and add some complexity in there, and then get numbers out of that experiment. Like we work with a lot of people on literally this, which is just proving the concept out, which is like we're going to do it at like an 1,000x reduced amount of time. And then it's just like, look, here's the best model, right? Here's what it looks like. Here's the best model that solved your problem. So here's the cheapest model that solved your problem, right? Because there's usually a cutoff somewhere. And then it's like, how often do you want to do this? How long are you going to have to update? Plus C for maintenance and interest, cost later, and potentially shifting between different models. It's usually a good way to go because then that can justify to the broader business, hey, we should break this task down. Because actually, again, to give an example, recently they've been working on, we're a class action law firm, we're doing legal discovery. We have hundreds of thousands of dollars allocated for manual reviewers to do this. um, can we get that? You can, realistically get that down 10x. It's just a matter of spending the upfront cost, and then it's a repeatable task. So yes, but I would say that if someone's like, yeah, again, I would like a multi-agent system to help me because I don't understand this. It's like you're about to spend some money on something that's not going to give you a lot of insight, I think.
Do you ever see people use like a general, like, as use a general model as an LLM to the RLL, like something to classify, like you use it to classify, and then you take the data once it's classified and use that to train your own model, and so you're not calling the LLM anymore. So and so it creates the data set you need in order to train your own internal model. Or do people, is that not really, because like I'm wondering, like, I feel like sometimes you might use agents in places where it's cheaper to use a different approach, and so
Yeah, absolutely, definitely. I think this is underrated. Sorry, I interrupted you.
no, I'm wondering if it's like you start with agents or thinking about agents, and then how do you identify which ones you could peel off and do it in a cheaper way?
Yeah. So to that point, absolutely. I mean, most modern LLM systems have some use of machine learning systems, like you talked about in the beginning, right? Like procedural if thens, not as used in my experience, but ML systems in combination, yes. And you can think that, like, again, if you want to look at like cost, it'd be like, okay, well, can a machine learning system do this? Because it's going to be way cheaper. And I mean cheaper in two ways. First, in terms of cost, and second, in terms of latency. Because like the majority of people, when they ask a question to an LLM, most of them are sending that over an API, right? Like across a wire somewhere and getting a response back. Privacy issues with that aside, that adds significant latency cost, right? And they also, the companies have rate limits that you can't necessarily lift unless you spend enough money with them. Then there's an argument around, do I host a model myself and get rid of the latency and cost? And then you're actually got a whole other area, which is like, now I'm managing a machine learning system. To that point, if you can like I have this example where it's like someone sent me like, probably 400,000 rows of Excel, right? And they're like, look, some of these are good data, some aren't. And I would like to know which ones are good and which ones are bad. And I would also like to do this in the future. I can use it, and these rows are relatively simple. They were medical descriptions. I can use 4.0 Mini. I just parallelize that and I can get that done in like 12 minutes. But I didn't say, well, I did say yes or no. I actually ranked it high, medium, and low. And then I just trained on the highs. I have the medium as a backup and I discard the lows. Now on, if they have that problem again, they don't have to use an LLM. There's now an ML system trained on that system. So LLMs can be very useful, what you described as tagging. If it's not really clear, like you can't really describe in like kind of like you can't tell an ML system what's good and what's bad, and you haven't tagged your data. But if you're like, hey, can you just make sure like this is kind of a good bit of text? Just be like, don't add spurious words. Like you can literally type this out. As a labeler, something like a 4.0 Mini can be really good for that, or like a Claude, especially. So yes, absolutely. Sometimes you can upfront the cost of an LLM, use that to train a model. In my experience, there's two main ways that's used. And it's actually really efficient use of cost because then the LLM isn't comparing to an LLM. The LLM is usually comparing to a human labeler, which is like significantly more expensive. So there's two ways. There's one, labeling. So classification in terms of labeling. You could be like, is this image blurry or not? That's a hard task generally, but it's really easy for a language model to do. Um, is this text only English? Right? Because there's a bunch of like, if you say, is this text only English? There are no publicly accessible like machine learning models that can tell you what slang is on Twitter. But if you give it to like an LLM, it's like, well, I know that this is Swedish, this is English that teens are using. Like you can delineate there really well. And then second would be extraction. Hey, Demetrius. Second main task going to be extraction. So it's like, hey, I have these medical records. Can you get me the patient name, the date of birth, and can you get me the condition and the specialist who treated them? That's a difficult thing if you're just like these medical records can vary across industries, right? And between providers. If you ask an LLM that, it's like, well, I can interpret this information and extract it consistently. And now you're training a model and now you can start to have it that way. So those are two really useful tasks that, again, the cost is actually pretty easy to justify. It's way faster and way cheaper than a human labeler. And then you can build an ML system from there.
I jumped in a little late, but I like where you're coming from on this.
Yeah,
Whatever you were saying sounds good.
Eric's got some great questions. The summary is that like multi-agent systems can get really expensive really quickly. Naively building one is not necessarily the right way to go. I'm bearish short-term and bullish long-term about this. A lot of it comes down to, can you design a system such that you know which ones need cheap models and which ones may need humans in that loop? If you can step zero that, then you have the potential to build a significantly cheaper, faster system. That step zero is a non-trivial amount of human time, which can be really expensive. So you have to justify it, maybe POC it, etc. And then Eric asked a great question around like, what can LLMs be used for to speed stuff up? And I'm like, well, when it comes to cost, if you compare it to human labor, it's often much better than comparing it to a traditional ML system. So things like, not like vague labeling or vague extraction, that's an amazing task to get LLMs to do. Again, like that medical records, that's literally something I've had to do. But I had to work with like 5,000 providers and they all write differently and they all call them different things. I mean, Eric, you can even do it in different languages. Like I have an Australian accent. You can do it with Australian, Polish, like whatever, however people speak English, you can extract. So that's really useful. And then you're just dealing with the usual ML systems and most people have them set up anyway.
It's funny when you say compare it with like traditional human, because it makes so much sense if you say, here's the baseline, which is very expensive, and then here's what an LLM can do, and you have to figure out what your like fault tolerant is there. But then the other piece is how a multi-agent system, if you have a human in the loop, can get outrageously expensive, especially if you're starting to scale. So you have to be smart about that. And one thing that I've been thinking about, and I'd love to hear your thoughts on, anybody's thoughts on really, is how the math doesn't really math when it comes to if you're doing LLMs or AI products, AI features for things that aren't like thousands of dollars of a sale price. Like for I know that it's become very common in e-commerce to use AI and agentic systems. And that feels scary to me because it feels like you're already operating with very low margins. And now you're adding these LLMs and the agents to the cost of goods sold. And you just can't make the math work, right? So I don't know if you've
Yeah,
played around with.
I think about this a lot. There's two examples I have. So my background is mostly in like mining oil and gas, like large scale resource systems, right? Like practical, like physical meets digital systems. With those, the costs and the profits, etc., are enormous. And so it's like
Yeah.
moving large, expensive physical goods. That is a great use case for what I described. That is very difficult. It's very like complex. It often has a level of regulation. Again, there's physical systems that are recording a subset of the data that you need. So that's very difficult. So they're like, look, it's not at the level we need. Conversely, if you look at like, where is the best chatbots historically? And it's like often e-commerce is one, but like in my case, it's like a utilities, like a phone bill, like an AT&T. I don't want to name anyone in particular, but like
But you
any,
just
no, I know, but like, there's nothing wrong with AT&T. But like, let's give an example. Their service. If I'm like, oh, I want something fixed on my phone, I'll go online and talk to their chatbot, right? Those chatbots are famously like they're fine, they're not great, right? So how much money do they actually want to spend making it good? Because I'm already using their service, right? Like if they spent money making a really good chatbot, like do I care? It's like not really. I'm already using it. I'm already used to using it, right? So the marginal cost there of like what might not even be a sale, it doesn't even justify it. And that's even high margin. So even a higher watermark than you just described, that math doesn't work. Because it's like, well, even if I made the perfect accurate chatbot, like does it matter? Most of that is human in the loop anyway, because I'm recommending them a web page as opposed to an answer. And then people can figure out their own thing. So, no, I think it's that you have to be pretty intentional about what you're doing. Same as like, uh, maybe like some site reliability engineer stuff makes sense, but something just like adding on to like a code, like you can see the coding agents are like basically free, right? Because like what sort of minimal
yeah.
effort does that add? So yes, where it makes sense is where often the existing labor costs, either through time lost, something like downtime, again in the resource industry, or like um, that the necessity for speed or the necessity for reduced cost is useful. But those are often areas where it's like there's already a lot of humans paid in this. And where I've seen the math work particularly well is not just like per hour costs of labor, but more like this task takes us like months. So just like from a productivity point. So for example, the best example is like right now, it's like December, right? Um, a lot of places are going to start to slow down in the next 2 weeks, arguably grind to a halt, and then start back up early January, right? So now it's like, well, can we get an agentic system running over Christmas? Because the relative amount of saved labor there is significantly more than like before the financial year, right? So that's when the arguments like I think start to stack up when you can compare it against labor. Comparing it against like cloud and machine learning costs, it actually rarely adds up. It's really just like we did a POC. It looks like it's going to cost a fair bit of money. Let's wait until the models get cheaper. And that's not a guarantee, but it's probably going to happen. So let's just kind of sit.
Yeah, I've also heard it as there is some metric that we have that is a strong signal. If someone does these things, they're going to buy our product. And so if we can use an LLM to affect that metric, or if we can use an agent that will help get someone over the line, then it shows a stronger use of that metric. Then it's obvious. But that means that your product has to be tens of thousands of dollars, right? Because then you're
Yeah,
like, oh, I spent 200K in LLM calls, but I got 2% more conversion on my $50,000 product, so it works out.
yeah, those make sense. Again, I was telling Eric before, like I helped a class action group with like legal discovery, and they're like, "Look, we have a budget of 300 grand. We have 2 months to do this." It's like, well, LN costs like pale in comparison to that, right? Like they'll spend any amount of money, even just to speed that up, because most of that cost is there. It's like this is what we budgeted for. It usually blows out. Like that's an obvious use case for this sort of stuff. To your point, I actually saw a counterexample to that, which is that someone's like, look, this is if people get to this point in our process, then they are likely to convert. So let's basically optimize this agentic system to get them through to converting. And it turns out that when you do that, then you actually change the profile of that customer. And now you're no longer converting as much as you thought. So like agentic
Uh,
systems can actually alter behavior. So this is for more of like this is e-commerce stuff, right? So I guess there's so many variables in that. Like if you're selling like again, I come from rural Australia, so like my example is always like farming equipment is just so expensive, right? Like I grew up with like John Deere stuff, and it's like knowing how much that is and how to convert people is like that's less of a problem, I think. If you can get someone to be like, oh, this is the tractor that's like a great sale. But to the point of like general e-commerce, the interesting thing I'm seeing is people are optimizing for existing processes and they're trying to agentically solve it. And it turns out that getting people over the line with agents isn't the same as how you got them over the line previously. So now there's a new paradigm emerging of like, what does it mean to actually interact with agents to get yourself there? So it's still emerging, man. Like it's fascinating. What I will say is that these experiments in e-commerce are actually good because they're relatively cheap and fast and everything's digital. But yeah, that's one of those cases. Oh, we're low on time. Sorry. Just
well,
realizing.
I don't know if
Gone
it
away
kicks
from
us out right now. We're gonna find out in 2 seconds, but uh,
Yep, we're being
okay. It looks like until we choose to exit, but we're being ushered away.
no
So,
worries.
oh no, here we go. All right. Well, I
Did you have any questions, Mike? I can try and answer before we jump out. Otherwise, I think you've got to go, Demetrius. You're closing, right? So
I just
I
have
can. Oh,
one comment that came up in a discussion last night when I was at GitHub. They were having an agent meetup with Llama Index and Arise and such. And the question in terms of the a shift that we are going to see in the development of our different processes and our applications and what the demand is going to be on that. So you're going to have agents. We're going to have agencies. I'm going to have my home agency. I'm going to have my work agency. I'm going to have my health agency. I'm going to have all of these agents concurrently working like microservices out there. and they are going to be competing, and they are going to be competing for my resources to be processing what I need. And a case in point that someone brought up, I can build this agency looking for a job for me and have it going through every single company, every single website continuously, always, all till it finds the best jobs and gets me the right interviews. How much compute power is that? How much LLM cost is that? How much environmental impact that we're now going to be
Yeah.
creating
Do
for
we even
sure?
have the electricity, right? Like that's yeah.
Because it's not just creating an app that gets me to LinkedIn to look at jobs. I have the multiple agencies running with all of these devices across the world burning power so that I can find these two jobs, right?
Also, the power and the money, like the compute and the money and the time, doesn't guarantee that it works. Is like the
Oh
biggest
yeah, it's not
difficulty at the moment.
deterministic.
Yeah. No, the teams at Llama Index and Arise, Phoenix are amazing, but they also sell platforms that
Well, no,
justify these. So I'm like, yeah.
they didn't bring this up. This was the discussion
Oh,
from the
nice.
crowd afterwards. Oh no, they were pimping their stuff.
Of
They
course. Yeah,
they
yeah.
were
Is this
they
in
were
SF? Did you go to is this the GitHub office in SF?
yeah.
Yeah,
From the
nice. Yeah, yeah.
yeah,
I'm based out of SF as well. It's a great office. Yeah.
yeah, and so
Um,
they had Vectara and they had
nice.
Crew AI, and of course they're all selling their agentic framework.
Yeah, 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 yeah.
But then
I'm
after the engineers got together and we started talking about, so where is this going in terms of how do I build these applications, right? And you got these emerging things like Fetch AI and Llama Index Deploy, where you're going to have microservices and multiple agents, and my agents hiring your agents, and all of the sort of rhetoric that you're hearing from people like the VCs like Jeremiah Ouyang, right? Promote it, and also the upcoming book from was it Reid Hoffman about this sort of agent universe that we're creating. And the question is, if we unleash this, and it's not the guy looking for a job that I'm worried about. It's the person who is in retail who is going to be at any cost. We're going to have this way of making sure you get that sale and be able to drive, or somebody in real estate or somebody in finance that they don't care. Like I just burned this amount of money, but you know what? We got all these sales and they're guaranteed.
Yeah, I think about it a lot. So it's my dad's a fireman, and I think often about like how does he resist these systems and how does he use them? And it just feels like a divide starting to happen, if not already. The only solace I take is that these systems currently are too dumb to do anything, but they're just really burning compute. But let's wait and see. Anyway, I think
Yep.
we got to jump into the
Yeah.
thing. Great.
Nice chatting.
Thanks, Thomas.